All right, Honors Chem, today we are going to start on oxidation and reduction. This is going to allow us to build on these concepts and finally learn, hopefully by the end of the school year, how batteries work and how we can use electrochemistry to derive energy that we use every day. We all have a battery in our pocket, probably several batteries that we run every day with our phone, our watches, a lot of our mice, our laptops, they all are driven by batteries, which is basically electrochemistry. So let's start with the basics so that we can build up to understanding a little bit of electrochemistry. Okay, so oxidation and reduction. A lot of chemists don't call it oxidation and reduction because it's really, really long and cumbersome. A lot of chemists will call this redox. And we get the red or the re from reduction, and we got the ox from oxidation. So if I say, hey, we're doing redox, you know that we're doing oxidation and reduction, okay? So oxidation, let's define a couple of terms. Now, before we define some of these terms, you have to realize that these terms came long before we actually knew what was happening with the electrons. So these terms are basically from when we saw oxygen glomming on to different metals. And so this is why the vocabulary is the way it is. It doesn't really make a whole lot of sense the way electrons are going, but the vocabulary is what it was when we named it 150, almost 200 years ago, and it stuck. So I'm going to give you a couple of ways to help remember it because it doesn't really make sense with some of what the electrons are happening. Okay, so oxidation is a reaction that involves the loss of electrons. So it's a reaction that involves the loss. I should do two S's here. Let's make that nicer. The loss of electrons. And I'm going to put loss in quotation marks because we know about the, matter can neither be created or destroyed. So these electrons aren't really being lost. They are going somewhere. We just need to define where they're going to. Okay? Reduction is the opposite. It's a reaction that involves the gain of electrons. Wow, I really can't write today. Okay, so when we think of loss and gain, okay, so if I'm losing electrons in oxidation, those electrons, lo and behold, are gained or they go to the element that is reduced, okay? So when I talk about electrons being gained, those electrons are taken off the atom that is oxidized and given to the atom that is reduced, okay? So that's where those electrons go. Now, the way that we can think of a reduction being a reduction, because usually when things are reduced, things are taken away from them instead of electrons being given to them. So think about electrons. They're negative. So the charge on that atom becomes reduced. It either becomes less positive or it becomes more negative. So the charge of the atom is reduced, okay? And in oxidation, the charge of the atom that is oxidized becomes more positive, okay? So that's a good way to think of oxidation and reduction in terms of electrons. Even though reduction is gaining electrons, that overall charge of that atom goes down. Okay, so let's talk about agents really quick. Now, agents are things that help us. So if I want to sell a house, I need a real estate agent. They will help me get my house ready, tell me what things need to be painted, what things need to be done, maybe make the yard look a little bit better so that my house can sell. Or if I want to find a house, they will help me find a house with the type of things that I want, like how many bedrooms, how many square feet, what neighborhood. They will help me find that house. So agents are helpers. They are helpers, okay? So the oxidizing agent is the compound or the element, the compound or the element that actually helps something become oxidized. So the species that is reduced in a chemical reaction. Okay? Because being reduced grabs those electrons and helps the other thing get oxidized. So the reducing agent, therefore, is the species that is oxidized in a chemical reaction. Okay? So remember, a reducing agent helps something be reduced. An oxidizing agent helps something be reduced. Or oxidized, sorry. Okay, so the other thing that we need to be aware of is the oxidation or reduction. The oxidation or reduction here, this happens to atoms. So this will be individual elements, where the agents can be elements if it's elemental, but if it's in a compound, these are actually compounds. So these are the whole species of what is either oxidized or reduced in a chemical reaction. Okay, so let's go on here. And it looks like my computer is stuck. So I have this picture of a lion here. And the reason I have a picture of a lion is it is a mnemonic that will help us understand oxidation and reduction. Now, I use the mnemonic, Leo the lion goes grr. So Leo stands for, oh wow, loss of electrons. So loss of electrons is oxidation. Okay, so loss of electrons is oxidation, and grr is gain of electrons. Is reduction. So gain of electrons is reduction. There's another way for you to do that. Now, there are other mnemonics that people use as well. Probably the other most famous mnemonic is oil rig. So oxidation is losing and reduction is gaining. So I really don't care which mnemonic you use, whichever makes more sense. This is the one I was taught, and that's the one I'm most comfortable with, so I'm going to stick with that one. Okay? So let's give you a couple of examples. So I have magnesium plus oxygen going to make me magnesium oxide. Now remember, when we have anything that is elemental, its charge, we've talked about oxidation numbers before, but we've named them as charges. Now we're going to use the real term for them. They are oxidation states. Okay? So remember, anything that was in the elemental form had an oxidation state or a charge of 0. So magnesium 0, oxygen is 0 in the elemental state. But when we put them together, we create an ionic compound. Magnesium is in that second column. And because it's in that second column, we have do you guys remember? A +2 charge. So you might want to bust out that column or that periodic table that we did way back in November, October. Okay. And oxygen, because it's in that third to last column, it has a charge of, do you guys remember? -2. Okay. So that means magnesium went from a 0 to a +2. And remember, electrons are negative. So that means we lost 2 electrons on that magnesium to go to a +2 state. So that magnesium loses 2 electrons, and those 2 electrons go to the oxygens because oxygen goes from 0 to a -2, so it gains 2 electrons. Okay? So magnesium is oxidized, right? Magnesium is oxidized because it loses electrons, and oxygen is reduced because it gains 2 electrons. Okay, let's look at this next one. See if you can do it on your own. All right, you ready to check? Right, so we've got 2 bromide ions plus chlorine, and then we have bromine going to 2 chloride ions. So let's assign the charges first. You notice we're always going to assign charges at the very beginning. And I'll teach you how to assign charges here really quick. So bromide is already a -1. So each of those bromides are -1. Chlorine is elemental, so it's 0. Bromine, elemental, 0. And chloride, that negative ion, is a -1. Okay, so let's look at bromine. I go from a -1 to a 0. And remember, electrons are negative. So I have actually lost electrons, right? I have lost 1 electron per bromine atom. So I've lost 1 electron per bromine atom, right? Let's look at chlorine. I've gone from 0 to a -1. So I've gained 1 electron per chlorine atom. Okay? So losing electrons is Leo goes grr, right? So losing electrons is oxidation. So the bromide ion was oxidized to make bromine, and chlorine was reduced to make chloride. Okay? So here we go. Let's talk about the agents here really quick before we move on. So, what helped the magnesium get oxidized? The oxygen. So, that means oxygen is going to be the oxidizing agent. And magnesium was oxidized, and it helped the oxygen be reduced. So, this is going to be the reduction agent. Okay, do you think you could do it for this? Bromine to bromide to chlorine, chloride? Okay, so bromide got oxidized. So this is the reducing agent. And chlorine got reduced, so it is the oxidizing agent. How'd you do there? Okay, here we go. Assigning oxidation numbers. Okay, determining oxidation numbers for a species within an ionic compound is easy. We've been doing this since we started doing ionic compounds way back in November, December. Okay, we've been doing that since really first semester. For instance, we have sodium sulfide. The oxidation number is for positive 1 for sodium. It's in that first column. For sulfur, because it's right under oxygen in that second or third to last column, is -2. Okay? But we need a method of determining a charge on covalent molecules and in other situations that are not obvious. Like, what about covalent compounds? They don't have charges, do they? It's a way of bean counting and keeping. Technically, yes, no, but it's a way of looking at where electrons are going. Okay, so here we go. Here are a few rules that make finding the oxidation numbers relatively easy. Okay, rule number 1. Atoms in their elemental state will always have an oxidation number of 0. We already stated that one. And we did that when we had our ionic compound. When we had elemental things, we started out with 0, and then we saw what charge they acquired when they made ionic compounds. So elemental, always 0. Okay? Step number 2, determine the most electronegative. So we're going to look for the most electronegative element in that compound, and we are going to give that element its charge. Okay? Now by that, I mean we're going to look at the periodic table. Let me pull up a periodic table really quick. We definitely want a periodic table. So let's go to documents. We want honors chemistry. And we want a periodic table. So here we go. Let's pull this one up. Okay, so if you remember, this column was a +1, +2, -1, -2, -3. Okay, now we're going to focus on the most electronegativity. So remember, electronegativity was maximized in this upper right-hand corner. So the big bad ones of electronegativity are in this corner right here. So we're going to usually assign these guys first. Okay? Remember, fluorine is the absolute most electronegative. So we're usually going to start with fluorine or oxygen. Okay? So next, we are going to, after we find the most electronegative element, number 3, the other elements in the compound will have a 0 or a positive charge. Okay? We are going to determine their charges algebraically. Okay? So you are going to have to think mathematically here. Remember, they can only be as positive as the sum of the oxidation numbers must equal to 0. Okay, so the sum of all oxidation numbers has to be 0. And they can only lose as many electrons to get those positive charges as they have valence electrons. So if you have, say, 4 valence electrons, but you're assigning it a charge of +7, that doesn't work. If it has 4 valence electrons, the highest it can be is a +4 because it only can lose the valence electrons. Once we start going into those inner shells, it's game over for oxidation numbers. Okay, so we can only lose valence electrons. All right? So the other thing to remember is that the oxidation numbers are the apparent charge. We can really only assign real charges to ionic things. And because we're not necessarily assigning charges to ionic compounds all the time, these are just kind of a bean counting tool that we use that's not really the true charge. It may or may not truly represent the correct or the real charge. Okay? So we're going to try a few in a minute when my computer allows me to start working again. We're going to look first at A, which is water. So when we look at water, what is the most electronegative element in water? Is it hydrogen or is it oxygen? It most definitely is oxygen. So we're going to assign oxygen its charge. And if you remember on the periodic table that we pulled up, oxygen has a charge of -2. So we're going to assign that oxygen a charge of -2. Okay, so let's give this a minute to hopefully sort itself out. So just remember, this oxygen is going to be -2. So if that water has to add up to a 0 and oxygen is -2, and I've got 2 plus, let's see, -2 plus what equals 0? +2. So I've got 2 hydrogens. So the hydrogens together have to add up to +2. So each of the hydrogens then have to be +1, don't they? So, wow, this is taking a long time to get itself sorted out. I'm sorry about my computer. So be patient. I might not be patient enough for this myself.